This is the Amp Hour Podcast, released July 7th, 2019, episode 450. Stories from Teardown 2019. Hey guys, this is Chris, and Dave's away this week on holiday, and so I thought I would post some of the interviews I did at one of the social events during Teardown, which is a conference that happened in Portland, Oregon a couple weeks ago. It's run by the folks that run Crowd Supply, and it was a great conference. It's now in its second year, and I think it was a really good conference again. These are a couple interviews with people that we know and you may recognize, and some new people as well. So hopefully you enjoy these. Trying to, the whole idea behind all this is trying to get the other part of conferences. A lot of the conference stuff that's on, almost every conference talk goes online eventually. And people might wonder, well, why even go to a conference anymore? I can just watch the talks. And what I want to try and impart is that there's tons of conversations that are going on. There's, when I say social interactions, a lot of people think just like drinking beer and hanging out. But it's really about making connections and learning more about what people are doing. And that's what I try and capture here. And hopefully you get this. Now, unfortunately, because of that, we're also in a party and, trying to get to know someone over audio. So there's always the audio stuff there. But the main thing I wanted to get across is that it's a really good opportunity to get to know someone and learn more about what they're working on and, make a connection so that when you want to talk to them about that work later on, or if you hear about something that might be a good fit for them, you can do that. And so hopefully that comes through here. I know not everybody has the means to get to conferences, but if you can, I do recommend it. I know for a long time I avoided them because I thought, well, I could just, like I said, I could just watch the talks online, or the talks aren't relevant to me, but it really is that other stuff, and that's what I'm trying to get across here. So this is a small picture of Teardown. Please let me know what you think about this format. I always love to hear your feedback. If you have any thoughts, you can always email feedback@theamphour.com. We'd love to hear about what you think of this, or there's always a comment section on the individual blog posts. Thanks a lot for listening, and let's get started with the interviews. All right, and we're back at Teardown 2019, and I'm talking to...
Hey, this is Jesse Vincent from Keyboardio.
Hey, Jesse. I think we have referred people to your blog posts and your past talks, and you've been in a bit of a long-term battle.
I don't think I'd call it a battle.
It's not a battle, it's a learning experience.
Yeah, and actually, our entire project was sort of intended as our learning project. This is our first piece of hardware. We had a reasonable sense of how little we knew.
So maybe you could explain what it is.
Sure. So we make our first product is the Keyboardio Model 1. It's a hackable ergonomic keyboard. The enclosure is milled out of 2 blocks of maple. It's got 64 individually sculpted keycaps. There's an RGB LED under every key, and it is of course Arduino programmable.
Oh yeah.
And we did a Kickstarter summer 2015. We ended up not really selling, but we ended up promising about 2,000 keyboards to Kickstarter backers. And then we
went for it.
We went for it. We'd previously gone through Highway 1, which was a hardware incubator. So we'd visited Shenzhen. We had some experts we were working with to sort of help us get set up with manufacturing. And visited about a dozen keyboard factories, got bids from about half of them, and ended up making a selection. And that's when it started getting really interesting.
Right. And so, yeah, you've gone through, here's some fraud in your past. Not in your past.
Right.
You've been defrauded.
And that's actually the spoiler for the kind of the end of the story, and that's fine.
It's like a Tarantino movie. You start with the end.
Yeah. And so we've delivered all the keyboards to our Kickstarter backers, and we've shipped thousands more to other customers. But we're continuing to do Kickstarter backer updates about our experience manufacturing, both what's gone right, and much more interestingly, what's gone wrong.
Right.
And we had more than your average share of problems. We talked to people who'd been doing this for 20 and 30 years, and every single problem we ran into the folks we know who've done this a lot are like, yes, that's a real problem that really happens to someone. But all of them kept saying, well, but these same problems don't all happen to the same people. You are extraordinarily unlucky.
You have a target on your back
Right.
or something.
And in this is not my first company, and in business I always operated under the assumption that one should never attribute to malice that which can be explained by incompetence.
That's right. I love that phrase.
And it turns out that in this one case it was enemy action. Our factory's director of overseas sales was a con artist who committed purchase order fraud, invoice fraud, and embezzled about $100,000.
Yeah, really rough.
It's been intense,
Yeah.
and we've been working through it. And it's one of the weirdest things is that nobody on the factory side seemed to believe it was happening because the penalties for this are so severe. This is 10 years to life in a Chinese prison.
Right.
If you go through with it, and she went through with it, and she's confessed to us in the factory that she did it, and they somehow still think she's going to pay them. But
Right.
at this point, the factory took full liability for everything. They signed a new contract with us, accepting criminal and civil liability, committing to delivering all the parts and a delivery schedule, and then they didn't do it.
Yeah.
So that's been interesting.
Yeah. Okay. Well, let's talk maybe more about the pod. And you've written about this extensively too. I think it's a great blog post.
Yeah.
I mean, it's tough to read, honestly. Like,
It's fun to write, as funny as that sounds. Like it's truthful storytelling.
writing like a train crash. Yeah.
Right, but it's like writing about things that are strange and difficult is worthwhile, both because it gets it out of our heads.
Yeah, that's true.
And it saves
therapy.
It saves other people from running through it.
Yeah.
And it's actually a hell of a story.
Yeah. I mean, you could sell the movie rights too, make up the cash difference.
At first, like, people are talking, say, "Oh, you've done all these updates. You guys should turn them into a book." And more as like the fraud came to light, and then some other weird stuff with the factory has since come to light. We're like, no, this is a movie. We're like, we'd rather do a Netflix limited series, but
Right.
Yeah.
Okay. So, I mean, in a best case scenario,
Yeah.
I mean, you're doing mechanical and electrical.
Yep.
And box build and everything.
Yep.
All in China, right?
Yep. Wouldn't do it anywhere else at this point.
Yeah, that's interesting too. I mean, like, so obviously, a lot of our listeners know about China.
Yep.
I'm pronouncing it right, China.
China, that's a place.
Okay.
Yep.
And what are some learnings, like high level learnings, that you would talk to people about?
Face matters, like being physically present. Like
I do always see your Twitter thing about leaving different airports.
Like I've always tweeted, like since I started using Twitter, I've tweeted every flight I've been on.
Yeah.
But being physically present and talking to people and having a relationship with people is hugely important. You learn about them, they learn about you. Unless you visited the factory and ideally visited a bunch of similar factories, you don't know what's normal. You don't know what's abnormal.
Right.
And watching things get made leads to much better design.
So I was going to ask about that,
Yeah.
because I was talking about that an episode or two ago about like being able to pull that back into the design process.
Right.
And there's some things where I've done something on a design and the factory's like, how'd you do it like this? It just doesn't. It's so far from our process. We have to charge you more.
Right.
I can imagine with the mechanical process is really that.
Yeah.
How do you end up pulling that back into your design process?
And so when you're there before the design is finalized, it can be iterative. Our factory didn't have strong EE skills, and so like their EE couldn't open Gerbers. It was not a good scene.
Oh.
No, I mean like their usual PCB fab. They'd prefer that we were at 1212 rather than 88.
Wow.
And we're like, we have a USB Type C connector. That ain't gonna work.
Right.
Like,
12.
So, keyboards, as it turns out, are mostly these 2-layer boards.
That's true.
Built
Big
on
the rubber thing.
or even the mechanical switches. It's like a 2-layer board, big fat wide traces, and like your connectors and your ICs are the tightest anything. Like,
Yeah.
And I mean,
So why pay for the whole board? you're saying?
and so they mostly use older board houses or older processes, and so they're not set up for historically aren't set up for Type C, aren't set up for tighter pitch components.
I see.
I can't imagine what would happen if I'd thrown a BGA at them.
Yeah, right.
But so the design revs for the PCB, I was printing out PDFs of the board, and their EE was drawing on them, and I was making the changes in KiCad.
Whew, okay.
But it worked, and it meant we kept control of the design.
Yeah.
We
It's true.
weren't.
Some people go over there. They say, "Well, then you do it," and then it's hands off.
I wasn't about to let them redraw our designs in pads,
Yeah.
which is the only thing anyone there used.
Oh, I thought they had like Protel still. Protel 99.
Every keyboard factory I've seen,
Interesting.
well, almost all of them are pads. A couple of the higher end ones have pirated copies of Altium.
Yeah.
And all of the all of the sort of lower end mechis seem to use the same pirated copy of Pro E.
Mm-hmm. Yeah. That's another interesting thing too.
Yeah.
So like, over and over, I hear from people who are like, you should go to, and maybe it was even you had done an HDG talk, which I'll try and link them to.
Yeah.
But it's like you don't go to a factory, just a generic factory. You found keyboard factory.
Right. I mean, there's specialized knowledge about making any kind of thing.
Yeah.
And we went to a keyboard factory because we had a sense of how little we knew.
Yeah.
And like visiting a dozen keyboard factories, you learn a lot. Like we saw everything from really high-end full automation, like a factory where they have a Lazy Susan in the middle of 8 robots that will assemble a mouse from components with no human involvement. Like really, like
Should I video that?
and I was not allowed. I can't give you the name, and I wasn't allowed to take even stills.
Yeah. Done.
To a third story walk up with no lights in the stairwells, where the woman operating the wave soldering oven was wearing 2-inch heels because she was going out that night. Like there is and seeing the high end and seeing the low end is super valuable because you learn about what's different.
You're paying for too, right?
Well, but also you learn about like what's normal and what's not.
Yeah.
And so we have a Chinese PM, and he accompanies me to meetings, and like his English is pretty good. And one of the things that I find is really valuable is I can turn to him and say, "Ken, that sounds crazy." Something the factory said, and either he'll turn to them and say, "That's totally crazy and not acceptable," or he'll turn to me and say, "No, Jesse, that's actually normal."
Oh, really?
Because like he has a lot of manufacturing experience.
Sure.
He knows not just what's normal for processes, but what's normal for processes in Shenzhen. One of the things that we ship with the keyboard is a 4-inch RJ45 cable to connect the two halves of the keyboard.
Oh yeah, right.
And
right.
when the first sample showed up, they had those little curved guards over the locking tab on the connector.
Yep.
And it didn't fit because those guards they interfered with our plastics, and we said we need them different. We need them without those guards, and they said no problem. We figured they'd change the cheap compression mold that they were using, because all of these things get made to order. None of this stuff is off the shelf.
Sure.
But no, it turns out they'd assigned somebody with an X-Acto blade to cut them off. So they've done 5,000 of them with.
Because
cutting.
it's cheaper than making a mold, or
Well, because it's the most
standard.
It's the most efficient way to get the thing, and they were starting with 1,000 that were otherwise bad.
Interesting.
Yeah, no, it's been a thing.
Yeah. What about the electrical side? Same kind of thing of like odd design choices.
There were so we spec'd a USB Type-C connector from Jayco because it's a nice high-end Japanese connector that we knew was good, and they're like, "This is crazy expensive. We can't source it. You should try the local ones." I'm like, "I'm happy to try the local ones." And in fact, the local connector was fine the first 50 insertions before
It scraped everything off the connector and it didn't.
before it not really connecting so well anymore. And so no, we need to use the Japanese connector. And I ended up calling Jayco's sales in the U.S., getting a referral to a sales agent in Shenzhen, and negotiated pricing. And they're still one of the more expensive things on the BOM, but they're worth it.
Right. And at least you also talk through your CM as well about no, this is why I want this thing.
And we do always tell them why, but at the end of the day, it's no, I want this, and this is we have an AVL for certain things, and like passives, I don't
That's
care.
Approved vendor list.
Yeah, sorry. We've given them a list of here are the people this thing can be bought from.
Yep.
Some things like resistors and diodes, it doesn't matter. We're happy to use local brands.
Yep.
Capacitors, we still spec either Korean or Japanese brands or
Right. Nothing local, you're saying?
nothing I don't
nothing
know.
unknown, right?
Well,
right.
and I totally believe that there are high quality local brands, but I don't know what they are.
Yeah, right,
And
right.
that's the thing where with a good factory, they can help. Our factory didn't have the sourcing chops.
Yeah.
The LEDs in the keyboard are by default APA 102Cs. They're Taiwanese. They have a tiny little microcontroller. They're really nice to drive.
Right. That's the dot star. Some people know.
Well,
Or no, that's the APA 10.
well, so they're similar to what Adafruit sells as the. Oh, I don't remember.
It's called dot star.
Well, dot stars were the old ones,
Oh.
no, the NeoPixels were the old ones. They're similar to what Adafruit sells as the dot star, but so we were using the Taiwanese ones from APA Electronics, and they were going through some kind of design rev or fab rev, and they were 9 months back ordered.
Ooh.
And so our maybe it's 4 months. It was a lot of months back ordered, and there are Chinese clones.
Of course.
One of them is known as the SK9822.
I've used those. Yep.
And in most applications, they work as drop-in substitutes. In our application, the SK9822s from 4 different vendors all buzzed. They caused the board to resonate.
Wow.
And the factory brought in the sales teams from like 3 or 4 different Chinese LED vendors, all selling what was supposed to be 100% compatible. And one of them's looked at it and it's like, well, there's a thing we can do, and we can do a different wire bonding for you that, it's like either adding or removing one of the wire bonds. It'll draw 10% more power, but it should be fine. And so they did a custom spin for prototypes for us, and they're like, you're doing an order of a couple 100,000 LEDs. There's no problem. We're happy to do a custom spin for that.
Interesting. Yeah, and it just seemed like the threshold is much
The thresholds
lower
are much lower than we would expect.
Yeah.
In general.
Especially, because LEDs wise, that could be like a low run prototype.
Right.
Of like,
Yeah.
you put how many LEDs on board? Hundreds of LEDs?
We put 64 in a keyboard.
64. Okay.
So we're actually like, it's nothing like the the LED panels that are 64 by 64.
Sure.
We're like one row of those.
Yeah.
But they do it and it doesn't fix the problem.
Yeah.
Another vendor brings in. They say, this is actually the guy who designed the IC inside the LEDs,
Oh, wow.
and he looks at it with a little magnifier. He's like, this is the old rev. Nobody should be using this anymore. In fact, we've sold the rights to it, so you shouldn't even be able to get these anymore.
Interesting.
And there's been some, one of the vendors like, you need to add more capacitance to the board. If you add 1 farad of capacitance, it will fix it. And so, if you're not familiar with what 1 farad of capacitance is, it's kind of like a roll of
I was
quarters.
gonna say it's a battery. Yeah.
Yeah, I mean, it's like a
D-cell.
Yeah.
Not really, but yeah.
And in fact, adding 1 farad of capacitance totally made the board silent. And I sent a picture of this to the LED vendor. I tell him this, and he's like, "That's great, you do that." And I sent him a picture showing this giant thing next to the keyboard.
Yeah.
I'm like, this isn't really going to work.
Right.
Also, when I unplug the keyboard, the LEDs stay on for 30 seconds because it's this
Just make that a feature.
Yeah, no. And so, in the end, we ended up having to delay production and go back to the real Taiwanese LEDs. We tried. We got a bunch of advice and tried adding various things to the boards to quiet them down, and nothing really worked all that well.
Interesting.
We did like 3 or 4 respins before I kind of drew the line and said, look, we're going to have to wait. We'll use the things that we know work that are, yes, they are 2 cents per LED more expensive.
Yeah.
And we're going to go back to the 4 design revs ago on the board.
Wow. But your clients could take that, you're saying?
But our customers, everything was already super late.
Yeah.
And we'd rather be super late and have something that's good than be super late and have something that is making a high-pitched whine.
Yeah, right. Especially because you're making these keyboards that are meant to be high quality and long-term.
And this is something where I hadn't originally noticed it, but I had taken a demo video of the LEDs and put it on Twitter. I had my air conditioner on, and and Scanlime's like, what's with that hum?
Yeah.
And
my ears are really sensitive to it these days.
But the fact that she could hear it through
a video.
A phone cam potato video
Right.
and just know.
Yeah.
It was amazing.
Yeah. That's good.
Yeah. No, it's been an adventure.
Yeah. So what's the current status?
So we have many keyboards in stock.
Great.
And so like we are.
That's a crazy crowd too. Like the keyboard crowd, it's like I don't quite get it, to be honest.
I mean, if you're familiar with the Japanese word otaku, like super fans,
Yes.
there are plenty of keyboard super fans.
Right.
And that's great. Our goal is to sell high quality keyboards to people who type too much. And so that does include a bunch of the keyboard community. It also includes a bunch of people who just type too much.
Yeah. Like you're saying for like ergonomics,
Like for,
help them out.
I mean, like people who, programmers or writers or, people who spend their lives at a computer.
Yeah.
These days, it's all of us.
Yeah. Right.
But yeah.
But in yoga class, they're like, "Oh, your neck's hurt, huh?
Yeah.
Wonder why."
Oh yeah. But yeah, no, it's been exciting. Like, we did our certifications in China.
Yeah.
It was interesting.
Yeah. How'd that go?
So we required that the factory start the certification process with things from the design verification run, not the prototype first, like the so what's called DVT instead of what's called PVT. Mm-hmm. So it was like they tested with a hand assembled board rather than a board from the first 100.
Right. Can you explain the acronyms real quick?
So design verification test and production verification test. And so there's also engineering verification test, which is the really janky hand-built thing.
Right, the Lego prototype and all that, yeah.
And what these things mean at a small company is very different from what they mean at Apple. Like,
sure.
But
right.
and different companies use the words a little bit differently. But the idea is we had the hand-built, what we believe to be final design PCBs, pre-FCC tested in China, because that's the time when we can actually fix it.
Right.
And in fact, it failed the first time. And the lab came back to us and they're like, okay, so the deal is that a retest is going to be $500 if you take it away and fix it. Or for more money, we'll take it to our lab, figure out the appropriate remediation, and retest until it passes. That's our value add service. And I'm like, so you said more money. How much more? And they're like, oh, that's another $100 US.
Deal.
It was how fast can we get you money?
Right.
And so in the end, we told them there's some bypass capacitors that you should put on the board.
Uh-huh.
Like we left a space for them that they might solve this, and they put them on there. Like, it helps some, but actually the problem is that your USB-C cable isn't up to spec and is not shielded like it's supposed to be.
Oh.
Just use a shielded cable.
$100 though. That's great advice.
Yeah, no.
It's like that the anecdote about the engineer and the piece of chalk and knowing where to make the mark.
Right. Yeah. It's like the old story is like, well, no, the bill is $5,000. It was $1. It was $1 to make the change. It was $4,999 because I knew where.
Exactly. Yeah.
But but going into the certification process, there was like they tell us we're also, to pass CE, we need to check the LEDs on the keyboard to make sure they're not too bright.
Oh, really?
Because CE actually has like it's a safety requirement, and they came back to us and said, so there's a problem. You didn't pass the LED brightness tests. The meter did not read any value. They're too dim, so you fail. Because the meter, and I'm like, no. If we're too dim, that means everything's okay.
Yeah.
And we had to get escalated to a manager who's like, oh right, that means you're exempt.
Right.
That's different than fail.
Right. So that's like a lighting standard, pretty much.
It's a
like if a child looks up at the light and
it's
burns out the retina.
Right. It's like you don't want to hurt people's eyes.
Right. That's it. I didn't know that was a thing though. That's interesting to know.
Yeah. But like touring the test lab, I became very, very glad that we weren't doing a Bluetooth device.
Oh, yeah.
Because Bluetooth devices have batteries, and those batteries need to be tested. And so somewhere I have a picture of the battery nail penetration testing machine.
Oh my god.
It is a machine that hammers nails into batteries to see if they explode.
Yeah. So we've had an Exponent, Exponent, the consulting company.
Yeah.
So one of my former classmates, he works there, and he worked on the Samsung thing.
Yeah.
And like they worked on like driving a truck over it and putting nails through it and all that crazy shit.
I've actually seen a battery company at CES showing off how awesome their batteries are. They have a tray of batteries powering something and a nail gun.
Oh my god.
And they're just like, it's fine.
That's a pretty good demo, though.
It's a great demo.
Yeah. It's a lot of batteries that you gotta.
I think if you're a battery company, it's.
But I mean, like that's heavy.
Yeah.
You bring a lot of.
Yeah.
It's not the biggest.
I think what other, we do extensively document sort of almost everything about all of the weird stuff that went wrong on our Kickstarter public backer updates.
Yep.
There's some things, legal things that we can't talk about yet.
We'll get there. Yeah, that's the movie. That's the movie,
Yeah.
right?
Well, no, it's like at some point we'll be able to talk about them, but we know that our factory has on occasion read our backer updates.
Right. Yeah, you don't want to bad blood.
Well, I mean,
burn bridges.
Right. That's true.
Yeah. Okay, great. Well, where can people find you online?
I am at Obra on Twitter, OBRA. The company is Keyboardio, keyboard.io. I am, if you want to email me out of the blue, I am Jesse, Jesse, at keyboard.io. That's most of the places I get found on the internet.
Okay, great. Thanks for talking to us.
Thanks so much.
All right. All right, we're back at Teardown 2019. And who am I talking to here?
My name is Adrian Studer, and I hack on radios.
That's right. Yeah, so you
Yeah.
gave a talk today, actually right after mine. It was great. It was reverse engineering. Can you tell us about that real quick?
Yeah, so I'm using like sub-gigahertz radios for my little side projects, which is a ship tracking device. And so I was always wondering, how does radio work on the inside? And so I found like a way to get the firmware out of the radio, and so I like pulled on a string and found more and more stuff that I thought was interesting.
Yeah, and before we go into that, let's hear a little bit about your product, because this is sold a lot of these things on Tindy, right?
Yeah, it's I call it like my little microcontroller project that got out of hand. So it's a AES receiver, so it's a tracking of ships.
What's AES stand for?
AIS.
AIS, sorry.
Yeah, so it's people are usually more familiar with Flight Track and Flight Radar and
like
ADSB,
Flight Aware 24.
Flight Aware. And so there's a similar concept for ships where the ships send out their position, and if you have a radio that listens to the right frequency, you can receive the position. And then there's open source software that everybody, it's not my software, but that everybody uses on their boats to navigate like the waterways. And if they have a receiver, they can see the other ships around them.
Oh, that's great.
And so I built a receiver for that. I don't have a boat. So
well, you're building the boat fund with
I
with
built
the
it
sale of the hardware.
like I'm kind of like train spotter, just like for ships.
Sure.
So I'm more like interested in tracking ships. And then I put it up on Tindy when somebody asked me whether I can buy it, and then it escalated from there. And
yeah, and you sold a lot of them though, right?
Yeah, a few thousand.
Yeah, that's great. That's great.
So yeah.
So what are people using if the software exists, but if they're not using your product, what are they normally using?
If they're not using?
If they're not using your hardware, what are they normally using?
I mean, the software works without it, so it's more like a navigation software for ships.
Oh, okay.
So they plan the route where they want to navigate, they see where there are rocks in the water or where the harbor is, and these kind of things.
Yeah.
And then there are commercial receivers for a long time.
Probably pretty pricey for those.
Pretty pricey. At least when I came out, the commercial receiver a few $100s. And the USB dongle kind of thing, cheap plastic, was maybe $100, and I sold mine for $60 on Tindy because it's kind of a different concept. I kind of locked into it. There's a lot of less hardware in mind than commercial receivers.
Sure. What's kind of in there roughly? What's some of the stuff? What's some of the stuff that's actually in the block diagram?
In the receiver, it's basically an MCU and a single chip ISM radio, so sub-gigahertz radio, and it's pretty simple concept. You just like the MCU tells the radio, listen on this frequency. I get the bits back and I extract the data. There's no encryption, nothing involved there, so it's pretty straightforward. And then I spit out a standardized format on the serial port.
Nice.
And then all software all navigation software knows that they have to, or they support that format.
So and then interfaces over USB, or what's actually?
Yeah, I use USB, and it's basically, but it's just like a serial over USB. The software just is a serial port.
Oh, great.
And then that's basically about it. And you connect your Raspberry Pi and can like transmit over the Wi-Fi with your Raspberry Pi, for example, and make use your tablet instead of a PC to navigate.
Yeah, that's great. It sounds like a really good like it's a kind of makery project, but it also has like a very practical thing, and it has the price advantage. So it sounds like a good.
Yeah,
mix.
and I totally locked into it. So it's, as I said, I don't have a boat, so it like people sometimes ask me like, what should I do to build something that sells on Tindy?
Yeah.
And I can't really give them advice. Like my advice is build something that you want for yourself. And
well, I've done boats and people have done airplanes. How about hovercrafts? Maybe motorcycles?
But it's more. I think it's more about put out there what you're working on.
Yeah.
And if you have an interesting project, people will find you.
Yeah. That's great.
I wrote on a forum and basically escalated from there.
Yeah. Well, and I think finding communities of enthusiasts too, whatever the enthusiast group it. I know people that do like camera hardware, and other people that do like game software and stuff like that. Like there are like I just interviewed Jesse. You talked about otaku, I think it was. Like people who are like really, really passionate about things. That helps a lot.
Yeah.
Okay, so you were now digging into that ISM band chip.
Yeah, so it's a bit of a rabbit hole. So my interest is I always want to know how things work, and if I see that there's like another level below what is presented to me, that always catches my interest. I want to know more about
Using
it.
APIs must take a long time for you then.
Yeah, so typically vendor with those ISM radios, they provide you a tool where you put in your frequency and like what encoding it is, and then they spit out the configuration file, and you're supposed to either send that configuration file to the radio or like SPI or I2C, or you get a vendor library that you have to call, and then it does its magic. And so at some point I was like researching something independent, and I found, there's a command that's called peek and poke, which is not documented, but they gave me the command number for some other reason.
Yeah.
And then I thought, well, there's a 16-bit address, and instead of trying just the address that the vendor provides you for that special purpose, let's like just try from 0 to 65535.
See what you get.
And then looked at it, what I got, and put a disassembler to it, and saw that it wasn't everything, and then kind of figured out on how to like get more out of it. So that's kind of from where it escalated.
Right. I think Alvaro is going to be like, well, hey, I should have be interviewing Adrian. This is reverse engineering.
Yeah.
I mean, have you done have you done a lot of reverse engineering in the past?
I did occasionally. So I did. That's like 10 years, 15 years ago. I did like a decompiler for obscure scripting language that was compiled for PBS systems. So I did like a decompiler for that. So I always like that like finding things out that people don't tell me. I also like it that I also, for example, I don't reverse engineer for finding security exploits or something like that. So I usually don't do that targeted thing. For me, it's more like mapping out.
It's just to satisfy your curiosity.
Yeah, satisfy my curiosity. Yeah.
And you talked about some of the tools there. Like, how, do you find it? I mean, I guess you've been doing it for a while. You built a disassembler, like you said. Do you still find it like approachable? I've always looked at it and I've been like, I don't really know where to start.
Yeah, it's the tools have a pretty steep learning curve.
Yeah.
It helps if you already know assembly. So I had like a background from like C64 times of really writing relatively big software in assembly. So it's kind of natural to read it. The tools I use the Radare 2, which is an open source tool, it's pretty low level, so it's like usually command line kind of interface, textual interface, terminal software. So it has it's pretty notorious for having a steep learning curve, and I needed to like write a few, like the 8051 disassembler was kind of broken, so I had to fix it myself. It's a typical open source project.
Right.
They're really open to accept your commits, but they're also very open to accept anybody else commits.
That's right.
So it's like a bit of a moving target.
Yeah.
More recently, there's a Ghidra or Ghidra or what
the NSA one you talked about.
The NSA tool that was released in January, which is much more approachable, I think, because it's like a GUI. You can like click on things and kind of explore things of how they work.
Yep.
That's to everybody's their own thing. And that's what you probably hear most about when you look at talks at DEF CON and so on. Everyone's using IDA Pro. And that's a commercial software that costs a lot of money. So there's a free version, but that's very limited. If you want to use like more obscure targets, it costs you like $1,000 or more to get a license. And
that's a lot.
So that's why I stuck to the free tools.
But it sounds like there is a lot of like maybe YouTube videos about how to do it. And
there are a lot of YouTube videos, and once you get the hang on, it's in my talk I compared it to a game of Sudoku. Because you take like something that okay, I have an API call that uses like this byte as a command, so you search a source code for where that byte's like compared to something else, and then from there okay, that might be that command, and the command takes like it sets a certain parameter like the frequency. It doesn't set that directly, but just as an example, so you know that wherever it writes that byte, which is the frequency, let's say, that address is related to the frequency, and then you look with Radare and similar tools, you can get cross-references, so you can see what other code is referencing that address I just wrote the frequency to,
right.
and then you can like kind of
Process
make some
elimination.
theories about what it could be, and the more you add, the more it makes sense. So like a Sudoku game, you get like a number, and then from there you get another number,
right.
that kind of game.
Yeah, that's cool. That's really cool. So then, like, how do you use this in a practical way then? So you're using this to basically reverse engineer firmware. Are you hoping to unlock new capabilities, or like, if someone comes up to you and says, like, Adrian, why are you doing reverse engineering? What would you say?
Entertainment. It's
okay. Yeah.
For me, it's entertainment. I know that
sure.
a lot of people do it. That's they're like very targeted. They say, I want to make that receiver to a transceiver. But for example, in my talk, I found out that physically they're identical. So what's preventing them to not be a transceiver?
Like
unlock the
features.
transceive function just by the receiver. I don't know whether that works. So whether there are other marks, but I'm not really interested. For me, it's more exploring.
That's cool.
Yeah,
That's cool.
I compared it to some people. I said you got like those adventure games like Ultima series, for example, or like all those Dungeons and Dragons, where some people play those to slay the dragon and get the gold. When I played those games back in the day, I was playing them to draw the map. I was interested to
you want to see the next cavern and see what else is unlocked there.
What's the dungeon? How does it look like? What are like all the bits and pieces? I wasn't interested in like slaying the dragon. And I treat firmware reverse engineering kind of in a similar fashion. So
that's great. And do you think that's made you a stronger firmware hardware engineer kind of thing?
It certainly it kind of teaches you some. So I'm not like a trained hardware engineer or firmware engineer. I'm more like in the like higher level enterprise software. So it's like different way of writing software, and when you work on that embedded software, you see how others are doing things. So I was presenting like a concept of how can you have a hard-coded firmware, how can you structure it so you can still have software patches if you have a bug in that hard-coded firmware.
Right.
And so they're like that kind of tricks that you see how it's structured and figure out, oh, that's actually a good idea. I probably should copy that from my own software.
Right. And I can imagine that being at a very high level, the likelihood or the interest in looking under the hood is probably strong because if you're at a high level, you're probably pretty abstracted from a lot of the things that's happening on a day-to-day basis.
Yeah, and for me, it's also a bit of a compensation of that. So I learned my ropes on the C64, doing it in assembly, and even early PC programming, I was doing in assembly. And only through my job, I did then like C and C++ and Java and whatnot. Yeah. And I always liked the low levels. So for me, it's I'm not comfortable if I don't understand the system from end to end. And the higher up you get in the software stack, if you try to understand everything that happens, it drives you crazy.
Exactly. Right. I always think about like trying to like hop between all the files and like you can right click and you see where it's referenced and it's like my god, it's just spaghetti. So that's great. Where can people find out more about you?
So I'm on Twitter at ADI Studer, Studer. So I occasionally post there, but from there you can kind of find the links to my projects. That's probably the easiest. Or just ping me if you have any questions or something.
Okay, great. Well, thanks for being on the show.
Thank you.
So we're back at Teardown 2019, and I'm with
Zach Archer.
My
name is Zach Archer.
He just waved at me. I'm like, okay.
Hi.
How you doing?
Yeah. We made it. I'm a developer. I have a software background. I discovered hardware in 2012 when I got dragged to a tour camp with a friend, and it was life changing. It was just incredible. So I had a background in graphics programming and animation. And I managed to kind of segue that. I found a home for that in hardware, and I started working with large-scale LED projects, all types of displays, and
right. And so it's one tour camp last year. I didn't get a chance to. I did a bunch of shows there, but you were busy. You were busy like crazy, building and live coding the huge sign that everybody saw pictures of that said tour camp.
Yes, it was the 40-foot long. Giant tour camp sign. I think that thing was about 8 or 9 feet tall.
It was really big.
Right? Yeah, it was huge.
Also for you, Zach, for scale, you're very tall as well. Yeah,
I'm a pretty tall boy. Yeah, I'm 6'5". It was a 500 watt sign, I think, at the end of it. It was a lot of work. I was really lucky that I had a lot of the tour camp staff to work with. We all put a lot of effort and love into it, but it was tough. It ended up being a lot lot of debugging at the end of it, and then and finally there was I think on the last night I did a bunch of live coding on it, and that was really exciting, like being able to sit there and craft these amazing colors and animations and across this giant canvas that's bigger than life.
How do you normally do that? So like, what are you usually writing in and stuff like that?
It was all it was all custom. It was
like
boy.
C, Arduino, like C++, like what?
It was my own made-up crappy language. It was
really,
wow.
Interesting.
Yeah.
And does that help for making the custom more custom kind of thing?
It was sort of just like I wanted to build this live coding stack and framework, and I had in mind just the basic, like a base set of features I wanted. So like variable assignment, a bunch of basic operators, but then also functions to shape data. Like make it really easy to have oscillators and things that can increase and decrease and do random things. So it's a language which syntactically it looks like JavaScript or C. I wrote a parser for it. It doesn't even have a name. It's
okay.
It was done pretty quickly. I should probably mention that the whole project was started and finished inside of 3 weeks, and that was it was a pretty exciting challenge. Yeah, I had to source the parts, build the boards, and then show up with everything in a truck and just hope we didn't have any major issues, so I didn't start a fire. So,
right. Yeah. I mean the high power stuff too. It's surprising how much that can impact your project, just wiring and making sure you got the right amount of power envelope, all that stuff.
Yeah, absolutely. We were probably it could have drawn a max of about 500 watts. I'm guessing we didn't do that in practice. It was probably more around 100 or 200. You have
a bunch of stuff sometimes on, sometimes off, that kind of thing.
Right,
so.
exactly. Yeah. We had a lot of visual contrast. Also, we would use a gamma correction, like to. It makes things look more visually correct to the human eye, but it also has the nice side effect of it reduces the overall power consumption. Like all the colors are skewed darker, basically.
Oh, interesting.
All the brightnesses, yeah.
I've never heard of gamma correction before. I probably should have, but
I'll send you some links later.
Okay, that'd be great. That'd be great.
It's good to know.
So what else do you use? I mean, what else are you working on that's similar? Are you doing other kind of display-based things like that, or like is this part of your work as well, like on a regular basis now?
I really wish that it was. I'm actually going to be working on another LED project for the next 3 months, and I can't talk about it yet. But if you circle back with me in October, I'll probably have a lot of
gee, what does that line up with?
Things to share. Yeah, right.
Things that happens with lots of LEDs in September. Okay,
right,
yes, very secretive, Zach. Yes.
Right. Yeah. I'm really lucky. I'm really more of a front end generalist.
Cool.
I really enjoy building systems to empower people and make these things really easy and really memorable. But I am known for my graphics and the animations that I do, and I guess that's I have people coming to me when they need like a level of visual, just like something special, like a level of polish in what they're working on, and I feel really, really blessed to have that. Yeah, it's amazing.
Yeah, so I've done some like LED matrices, stuff like the IS 3731 or whatever they are.
Sure.
FL. Yeah. I don't remember the part number. It's also on the borrowed from the Ada Fruit Featherwing family kind of thing stuff. Yeah. And like I got to implement it and stuff like that, and I can get demos up and I can turn on individual LEDs and stuff like that. But then it's like, well, I gotta make this look cool. Like to make it look cool, it's like a whole nother level that I never really you don't consider until you get to that point.
Yeah.
And really that should be considered at the beginning. Some people in the badge life community, they even write simulators first and think about how it's going to look and then back calculate it to the hardware. Right. And that's a really cool way to look at that. I mean, are you doing that kind of same thing, simulating first and then building or using hardware, or how does it work?
If time permits, then I love doing that. Yeah. I actually did that for a project last year. It was another LED wall. I actually made a whole 3D simulation, kind of like Doom.
Wow.
So you could walk up to it and see and like kind of get a sense of how it was going to feel in real life. And yeah, if there's time, it can be really good to do that. I feel like oftentimes you don't have that luxury with these, kind of like graphical projects. But I love doing things like that. And I definitely agree. Coding graphics is its own kind of weird way of thinking. It's something that you don't normally get to practice, right? It is, it is kind of like a skill, but then also kind of like an art, that you just have to do and practice to get better at.
Right. Well, the translation from the, I think about screens and the stuff that's on screens, and obviously that's every single day we're all using phones and computers or whatever. but like I don't really consider like, of course someone had to write that and deal with that and then translate it to the physical level too, right? At some point there is a bit that's turning on an LED that hits my, turns on a photon and hits my retina and blah blah blah, right? And like, and it's like I'm always at the photon emission point, but I'm not at the zooming way back up to the make it look cool thing.
Right. Yeah, it can be really tough. If you can practice like visualizing something moving in your head and then break it down into like how would you represent that across time? It's like where do the pixels have to be 1 second from now and 2 seconds from now? And if you learn just if you can get a handle on basic trigonometry, that is I think the single most hugely helpful thing. Just like really get a handle on how sine and cosine relate to each other. That's hugely powerful. Any math you can pick up and kind of do in your head, it opens more possibilities to you graphically. I would definitely recommend that.
Interesting.
Yeah.
Now you've also you weren't able to give the talk yesterday, but you were supposed to give a talk about e-ink.
Oh my goodness! Yes.
So tell us about the e-ink stuff. What's going on with that?
Yeah. Okay. I am most likely giving this talk tomorrow.
Oh, great. Okay.
Yeah. And they're
Preview.
Right. They're going to give me another chance and put me back on stage. Yeah. I had an emergency yesterday,
of course,
unfortunately.
Yeah.
But everything's going to be fine. So the e-paper. I was I got a board from Drew Festini of Osh Park a couple years ago.
Are you a friend of Drew? No. You do have a pin?
I adore Drew. Yeah, I got my official friend of Drew pin.
Yeah,
I see we were both friends. Yeah, we're both friends of Drew.
Right.
Yeah. I was really curious about the e-paper panels, and I wrote an open source library for drawing grayscale images on them, which is something that you have to kind of do as a hack. It's like they don't support
like dithering
that.
between like for like 16 scales of gray or whatever.
Yeah. It turns out you can actually have as many bits as you want of grayscale if you draw enough times. I came up with a technique where each bit of the image like of the image's a bit depth, you do one draw for that bit. So you could have like 100-bit image if you wanted, which would be overkill, right? But
sure.
Yeah. It's they're interesting. I found them really tough to work with. I'm giving a talk tomorrow about just things that I learned and using them over the past 2 years. I actually stopped developing my library. It grew and grew, and it became
just because of the amount
of
the new things that are coming out, you're saying? Or
yeah. And then also it was like I was trying to solve problems that were basically impossible. There were these 3-color panels, and I thought, wouldn't this be great if I could get grayscale and color gradients on them? And then it's a fascinating problem, right? And
especially like how those work too, because they do like a positive, 0, and like negative, right, to get the red or however they do it.
Yeah, it's okay. Yeah, so there's a lot of secrecy in the e-paper industry, right? Okay. I think what's happening is that the black particles and the color particles, like the red, they have the same charge, but then the red particles are somehow they have a different physical property, like they're actually larger and they have more inertia, so it takes them longer to get moving.
Got it.
So if you can simulate this in your head and kind of work backwards, you can figure out how to actually make a pixel red, and the red particles you basically have to have them race the black particles to the glass.
Interesting.
Yeah. And you have to set a setup of the particles so that they're all in the right place for that to happen. And basically I gave up. I realized that what I wanted was just impossible, and that I felt like I couldn't go much further with it. I still love these displays. They're maybe not the best choice for a general purpose display or for something that you're going to update a lot, but I really like them. I feel like we really need better low power
like
displays.
High brightness in the sun kind of thing. Like it's like every time I take my Kindle to a beach, I'm just like, this is such a great friggin' invention,
Yeah.
Like,
It's amazing.
And the fact that it's low power too. I mean, I think a month per charge or whatever it is.
Right.
It's really crazy. So
yeah,
that's great.
Yeah.
So you'd mentioned, you kind of write frameworks on top of this stuff. Is there a good framework that you would recommend? So like hardware person,
sure.
Like what would be a good place for me to get started as someone who's like, hey, I'm going to need graphics. Maybe I'm going to design something with LEDs on it, whatever. What would you say is like modeling something before putting it into hardware, or even as I'm putting it into hardware, so that I make better stuff?
Wow, that's that. Ooh, well, that's a really interesting.
I'm not going to write my own
like,
custom thing like you did. I mean,
okay.
so are there off-the-shelf type things, or is your thing available? Like, how does that work?
You are free to go to my GitHub and my Bitbucket, and if you contact me, I can show you what I've done. I don't really have any structured named open source projects like this is a thing that does XYZ. I have a lot of code that I've kind of copied and pasted and mutated throughout the years. I am sure that there are frameworks out there for showing you a simulated version of what's going to be on your display, when X and Y happens. I couldn't tell you what they are. I have always done it custom just because I find it quick and easy because I've done it so many times.
Sure.
So
maybe let's walk through it real quick. So you're gonna start something custom. Where do you start with then? Are you starting with like, I know this is gonna be like a 20 by 10 matrix, and then I code that in, or like, how are you actually and then like translating stuff? How are you actually thinking about that kind of thing?
Oh, yeah. Well, for something like a 20 by 10 LED matrix, I started doing it. I started writing everything so that it runs in the browser because it's such a capable runtime, and because JavaScript is really easy, right? Okay. And for something like that, you could use just a basic HTML canvas. If you knew that you were going to grow it, you could use WebGL or something if you wanted. But there are frameworks to make drawing things in the canvas and WebGL easier. I would probably lean on that.
Okay.
In fact, I would definitely lean on that. The rest of it, I mean, writing these frameworks that do simulations of your other project, I don't know, I just find that kind of fascinating, and there's a real joy to it. It's like
like instant feedback for sure, right?
Right. Absolutely. That's really great. And then also it gets you really sort of like, it gives you this deep familiarity with what you're about to go and build.
Right.
And
that's true, right? It's like you're basically building a spec for this thing, because you're like, I'm going to have it do this and this and this, and it's like, oh shit, I can't do that. So
Right. Yeah. And I guess then maybe that's a difference between doing like a schematic or some kind of other hardware spec or something. I'm making sort of a graphical spec for these things, right? Yeah. It's a different approach.
Well, and I think it's really good. It's like user centric type of thing, anyways, right? So thinking about what the end user is going to be, or you as the user of the programming environment as well, like how you're going to use it. I think my problem, and maybe other hardware people's problem, is I think about just like, how do I get a thing stuck to a board? Like that's kind of the immediate focus, but really, at the end of the day, most people don't care about that small individual thing. They care about the end result, right? They don't care that it's a matrix of LEDs. They don't care even about that it's an LED. They just care about the blinking thing or what the end result is. And like having that focus kind of seems like your method kind of thinks about that first.
Sure. Yeah. Actually, I feel like this is part of the process for me. I try to focus on how something is going to feel, or like how people are going to respond to it, or like is it really special in some way? Does it kind of try to break outside of its own boundaries or something like that? I always love it when you have like a display which is not a rectangle, but it kind of like breaks out into reality. It breaks out in like other weird shapes, or there's backlighting or something like that. It's like, that's always really interesting. And I think it's actually it can be a good practice before you start developing anything. Like, think about the best possible experience you could have with this thing that you want to build. It's like, what is delightful about it? What is enchanting about it? Like, what could you put in it that would make it something that you would be proud to show off to everybody, and make it feel really new and really exciting. I think that's important. That's something that I try to bring to everything that I do.
That's great. Well, where can people find out more about you and your work?
I have a website which is controlzinc.com. And
INK or INC?
INC.
Okay, like a company,
Right.
Okay.
Yeah, exactly. Right. And I'm on Twitter and GitHub as ZK Archer. And I have a lot of videos and pictures to check out in all these places. So
awesome.
So definitely take a look and get in touch with me. I would love to hear from people.
Okay. Well, thanks for talking to me.
Yeah. Hey, thanks for having me do this. This is great.
What are we talking about?
It's just to catch up with the Amp Hour. You guys are like regulars, so.
Are we?
Yeah. Yes. Welcome back. We're at Teardown 2019. Who am I here with?
It's Piotr Zdentemski. And this is Jeff Kaiser.
Yes, sir.
Yes, sir.
How you doing? I heard someone say if Jeff was going to be on the show, they're going to lose their shit because it's not Christmas and they don't know what time of year it is.
I know.
Yeah.
I've already had this conversation. We have an agreement on the Amp Hour that I'm on once a year, no more, no less, and it's always at Christmas time. So
It's Christmas in July.
this is a potentially destabilizing
You're
event right
breaking the
now.
time continuum.
Right.
Yeah.
Yeah.
So, that's good.
But it's good to be back.
Hey,
Thanks
man.
for. I'd say having me on the show, but you're standing right here,
I
so
know,
it's kind of a
right.
different vibe.
Looking in each other's eyes is kind of weird. So,
Yeah.
we both took Peter's workshop today.
We did.
Very nice job.
Yeah, it was awesome.
I enjoyed it. You said it was designed by Clifford. I didn't realize that. You
Oh,
were stealing.
So this story is quite interesting. So originally the workshop was done by Joe Fitz.
Oh,
as
cool.
You might
I didn't know.
Guys
Yeah.
know, yeah.
Yeah.
And he had it done with Xilinx FPGAs back in the day.
Okay.
And I'm trying to figure out. I think I wanted to use the Icebreaker and do a workshop for it. And I talked to Joe, who is also here, Portland local,
But not
and a
at
friend.
this conference. Yes.
Yeah, he couldn't make it, unfortunately, this time. He had a family
That's fine.
event. And he was like, just take my WTFPGA workshop and just go with it.
Okay, so I've heard of that before, yeah.
So yeah, I converted it to
Yeah,
the Ice 40
Yeah.
to the. So I flossified it.
Oh, because he was using a Xilinx toolchain.
Yes,
Yeah,
he was,
cool.
and it was funny because he's using this Chromebooks with Ubuntu on it,
Yeah.
and synthesizing the simplest thing took like minutes.
Yeah. Right.
So he has a section, and there's still the section in the guide where it says, "Oh yeah, now that it is synthesizing for the next few minutes, we can talk about several things."
Right.
So
Yeah.
this is now gone. So I still left the text in there with the tongue-in-cheek mention. It's like, yeah, I know the synthesis now takes seconds,
Yeah.
but let's talk about these things
Right.
anyways.
Right.
I remember years ago there was a project, the Papilio Butterfly.
Oh, yeah. That's right.
You remember that?
Yeah.
And
It's like
the first
accessible
step-
FPGA type stuff.
Right. It was one of the kind of early
Oh, yeah.
accessible FPGA projects, and one of the interesting things is that the first thing is you go and download the toolchain,
Right.
and it was like a multi-gigabyte
Oh
download.
yeah.
Like
I remember,
literally
I remember
gigabytes of
Xilinx 14.
IDE.
It was a F16 or F14 like fighter jet on the CDs. There were 10
Yeah.
CDs.
Yeah.
Holy crap!
Yeah.
And like you just get a book of them,
Yeah.
like, and it was like the old like floppy books, when you get like floppy disk.
Well,
Yeah.
at least you had something that you could weigh the money you paid for it in weight of the
Yeah,
booklet, right?
Yeah. So this was actually my first time using the Yosis and the NextPNR. NextPNR? Yeah, it was NextPNR. There,
Yeah,
right?
there was next PNR this time. Yeah.
So I was very happy with it. It's super simple. I mean, Jeff, you took it too. What did you
Yeah.
think?
Yeah.
I thought it was great. I mean, the
Thank
cool
you.
thing is that the whole tool chain was all set up, ready to go.
Yeah.
I've been at conferences where you spend the first hour downloading
Yeah.
the tools, and
Yeah.
everyone tries to download them at once, and the internet
Right.
goes down,
Yeah.
and it's
Right.
just
Well,
kind
and you
of a
had
bad
Joe
experience.
Fitz's laptops, which I think is a
Setup,
great
yeah.
way to
Yeah.
do it.
Yeah, it was really
Yeah,
good.
this simplifies the upfront cost of installing the software because the tools, as you know, they're still moving so fast forward that as soon as you have a binary package to install, it's already outdated.
That's right. Yeah.
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 And so I actually made a script to build all the tools and the
Let's walk out here.
summon FPGA tools. And it's you can install it on your own laptop, but it still takes like half an hour depending on your laptop
Yeah.
because you have to compile it.
Yeah.
But so I did the workshop again for CCC last year, and Clifford and Edmund and Dave Shaw and a bunch of other guys from the
Oh, actually,
Open
you guys
FPGA
recorded there, at the Congress, rather, right?
Yeah, it was a congress, and we were doing the workshop,
Mhm.
which was fun because we were doing batches of 8 people, and we did 10 workshops.
Oh, wow.
It was painful.
That's a lot.
But it was great that people were interested. Still, we managed to get 80 people through the workshop.
Yeah.
But while the workshop was going on, Clifford was looking at the guide and was like, yeah, but this is not synchronous logic. Why are there sensitivity lists on buttons? This is not what you do. This is painful. So he basically, during the workshop, wrote new set of exercises instead of the calculator. In the WT FPGA, it is a stopwatch now, and this one is more something a Verilog programmer would be okay with.
Right.
And
let's talk about that real quick too, because this is my not second time, but I mean, like, I have not used FPGAs in a while. I've done some Verilog stuff in the past. I've done VHDL a lot more than that before that even. It was kind of rude reintroduction. Maybe Jeff, you can.
I totally agree.
Jump into
yeah.
Like it's.
I promise I will polish it better.
No. It's synchronous versus asynchronous programming.
Right.
It's asynchronous programming breaks my brain.
Yeah.
I'm used to being able to read the code and have some idea of the order of execution.
And this, and it's like, and it's just, and you just have to keep reminding you need like a tattoo that you look down and you're like, you're making logic. You're making logic. You know what I mean? Like,
it's not sequential.
It's making logic is like making it into an actual gate is the important thing to remember, right?
Yeah. I think this is the distinction between programming a processor, for me at least, versus writing hardware. Is if you write software for a processor, it is sequential by default, and you have to work hard to make it parallel.
Yes,
and it's for Verilog, it's the complete opposite. You have to work hard to make it synchronous and do it as sequential.
Properly. I almost feel like there should be so I was using VI to do the code editing. I almost feel like there should be syntax highlighting for the sequential versus asynchronous order of execution, right? It's like, show me graphically like which statements are being executed at the same time, and have it be, because for a beginner, it's all too easy to fall into the trap that top to bottom on your screen is the order of execution.
Especially because I think a lot of people, like, the tools are getting much more accessible too. And like thinking about people that are going to be coming from Arduino or beginner intro type stuff,
right?
And it's like, man, it's there's something in there. And I think, like I said, I think it was a great workshop, but it's like something of just switching the brain over. It's almost like it'd be better if it was just not code at first, you know? If it was like, let's just look at some logic diagrams, and here's what we're going to do, and then translate it back to code.
So this is a very good pitch to say that iStudio is a software written by these awesome guys, FPGA Wars group. It's a UI that is graphical, has blocks, and you can connect them together. It's very, very friendly for beginners. They are teaching a lot of kids. It's mostly, at the moment, Spanish-speaking community that is using it, but there is plenty in English, no worries. So you probably there should be also a version of the workshop that is using this. The nice thing about iStudio is you can have blocks that you connect with wires and make basically schematic diagrams, but in the blocks you can also write Verilog itself. So you can transition, so you can start with the pulling traces and putting blocks, and then transition into writing code.
That's almost like how what's the National Instruments tool? LabVIEW?
LabVIEW, yeah.
That's like what LabVIEW does, right?
Yeah.
And then you can dig in and write G or whatever they call
it. I just personally am not a great fan of like graphical programming tools.
I totally agree.
Really? Why?
It's hard to read someone else's code. I mean, it's hard to look at changes between versions. Versioning is really hard. It's also just hard to understand. I think as humans, we just don't have a good way of like reading a map and kind of grokking everything about.
It depends on how complex it is. So this is apropos the talk we had at KaiCon about doing schematics and then becoming more and more.
Dave Vandenbout's talk about what do you call it? Skittle?
Yes.
Yeah.
And
so, I'm sorry, context for that is Dave's basically taking it in the other directions where we're all used to schematics. He then wrote a tool that then basically makes it a text description of it. He's basically making like a Verilog kind of thing for schematics.
Yeah.
Which is a cool idea, but very hard for me to understand, especially after all the years of graphical.
Yes, that's. But he made a very good argument and a very good case
no
for
doubt.
his approach, because he said at the beginning and to a certain complexity level, it all making a graphical make sense and having blocks and having wires and whatnot. But at some point you have buses that have 64 signals, you have to connect them to 50 places. It becomes so complicated that the graphical stuff just doesn't cut it anymore.
Right. And it's very likely to miss something.
And when you write VHDL, anything in FPGAs, this happens really quickly. You have an AXI bus, it's a lot of signals in a lot of places to route it to. So making it in blocks and having modules that you connect together.
Right. And Dave does a lot of FPGA stuff too. All right, drop the recorder. We're still recording. We're still recording. Yeah.
Did you guys see the long tail talk this morning?
Yeah.
So Steve, right,
That's right.
was
Microsoft
talking about a group had done an extension to fritzing that had sort of
AutoFritz?
Done AutoFritz, which is basically autocomplete for hardware, which I think is an awesome idea. I would love to see that in CAD tools. Wait, well, I mean, think about it. Like, let all the decoupling capacitors, all the crystals, all the stuff that's just the same in every single design, to be able to instantiate a component and then just get all that stuff. And I'm not saying you still have to think about it, but I think that to me that's really interesting. I've never heard of that for hardware before.
Yeah.
Well, I mean, Don't Make Me Think is actually a book. It's about like user interaction design.
Okay.
And that's not like Don't Make Me Think at all, but like it's actually the book's called Don't Make Me Think, and it's about that of like making decisions easier for users, and like if you know like a lot of the systems that we're used to, right, and like let's pick on KiCad a little bit, right? There's just like dialog box, and it's like as a new user, you're like, oh my god, right? And you know, you think about like good user interaction design type stuff. It's intuitive. It you know, it matches other standards that are out there, that kind of thing. So that's what I meant by Don't Make Me Think. So same thing of like adding in capacitors, like might be like a natural thing of like it's not quite clippy, but it's hey, you put down a processor, there's probably going to be these things around it.
Yep.
It's just kind of reminders.
It's a little bit of a templating
sort of
system.
Focus on the differences between applications rather than the stuff that's always the same.
Right.
Yeah, that's nice.
Yeah, cool. Well, any other talks or things that you guys are? Your workshop was cool.
Thanks.
What else have you liked so far?
Oh gosh, I saw a talk about using Python and Python's Jupyter Notebook to do kind of data collection and analysis and plotting.
Hold on, I lost your audio. Did I turn you down? Can I try again?
1, 2, test.
Yeah,
yep.
we're good. Sorry.
I saw a presentation today by
Chris Osterwood.
About using the Jupyter Notebook to do Python data collection and plotting, which I think is a great idea. And that's something that I've used in my day-to-day professional life before. I think there's a ton of potential there to use Python for applications that historically LabVIEW and other proprietary tools would have been used for. I now want to go and play with that stuff more. I just think that it's like I see the promise there and the ability to use things that are not proprietary Microsoft desktop applications to do scientific data visualization and data analysis. I think that's really exciting. So I thought that talk was great.
Yeah, definitely. I'm really excited. I'm going to try and get to the FOMO thing. So I'm going to try and talk to Tim and Sean Zabs Cross, who's here too, Tim Ansell. And they're talking about FOMU, and they're doing a workshop too, and that's also FPGA based and has a RISC-V on it, and like I'm very interested in like all that stuff.
Yeah, it's really they took the really tiny like
form
flip
factor.
chip, WCLSP. It's a gorgeous design too.
Yeah. I had been asking him like, well, I don't get why there's not any interfaces to it. You know, it's just an LED and a couple inputs. It's not like user interactable, but it's actually like about building up the tool chains, and you know, you run GCC on the RISC-V that's on there, that's in Logic and blah blah blah.
It is a development platform for FUPI, the whole like Python full stack Python, where you have the SOC and the programming and everything is done in Python, which is an interesting approach. Yeah. I wanted to give a shout out to one thing here at the event. It's not a talk. It's actually an installation. It's the Church of Robotron.
Church of Robotron.
Yes, that was great.
Yeah.
Did you
So
all get tested?
I did.
I was tested. Yeah.
I have.
Yeah.
I am not the savior. So, why don't you explain what it is real quick?
So this is a trailer where there is the arcade game Robotron installed inside, and it's basically made into a
new thing here. I think we're okay still. Yep.
So it was actually an idea, an installation, a group from Portland, Jared Boone and a bunch of other guys were putting together for tour camp many years ago.
I was there.
You were there?
I was there.
Yeah, this was 2 years before my first tour camp.
Okay.
And I missed it.
It was amazing.
Yeah.
It is amazing here, but seeing it for the first time was really incredible.
Yeah. It's a reiteration of that, and it's actually the whole thing is implemented on an ECP5.
Oh, really? Wow.
Yeah.
That's great.
With open tools.
Wow, that's great.
So the whole machine, but yeah, there's a scoreboard, and it has like a story to it where it's you are the mutant savior that has to save us from the robots that are coming, and you are being tested because
it's like a filtering program for the best human.
Yeah, it's a great idea.
Yeah. That's great. Well, guys, thanks. We're all going to be at Chaos Camp hopefully this year, and we'll talk more, I'm sure. And we'll have Peter at more events and Jeff at Christmas, and we're sorry to have upset the time continuum here, but it was worth it. You know what? It was all worth it. Thanks, guys.
Awesome. Thank you for having us.
Yeah, thank you.